All right, thank you. Thank you for the introduction, and thanks everyone joining us today. Later on a Friday afternoon at the end of or towards the end of a really exciting CloudStack conference this year. I know you guys are probably eager to get home to your families soon, but we're super stoked to talk to you today. A little bit about us, but mostly about what we've built over here. Before we jump into that. A little bit about us. We're a cloud service provider, a US-based cloud service provider. We believe in a free and open internet. We believe in reducing costs for the cloud and providing exceptional support for customers to reduce the complexity that's come with cloud over the past 10 to 20 years. Like I already mentioned, I'm Aron Wagner. I'm the CEO and co-founder of American Cloud, and with me I've got
I'm Ben Linzel. I'm the principal software engineer at American Cloud.
And so, yeah, today we are going to talk about building a new CloudStack usage service. We found that the current CloudStack usage service that was available didn't really fit the bill for what we needed to do as a cloud service provider. And so, with that, what we did find is that there were the tools available for a foundation to build a new usage service that then we could take further for our specific purposes. So I'm going to hand it off to Ben to talk through our build, and then hopefully we've got a really exciting Q&A at the end.
Thanks, Aron. Yeah, so just as an overview, what we built was our own real-time event-driven billing engine based off of the CloudStack event schema that's already provided within CloudStack, which the usage service already uses as well. And I'll explain some of the details and the differences between our billing system and the CloudStack usage service. So first, I'll explain some of the limitations from the existing CloudStack usage service. So first of all, one of the main problems with the usage service is that it has to be specifically invoked on a schedule. So it's not a real-time data system. It has to run on a schedule, which means that the data is delayed. And because it's not a real-time system, customers don't have insight into their current usage. They have to wait until the next time the usage service runs. And from an administrator standpoint as well, this is not ideal because we also can't get immediate feedback for the current state of a user's usage. So running on a schedule is problem number one. The second problem is that the usage service itself has to run on the CloudStack management server. And this is a problem because the management server is busy managing the resources in CloudStack. And you don't always know how much headroom you have on that management server. Maybe the management server is appropriately sized for the amount of work that it's doing, but the usage service, when it runs, increases the load on the system. And if the system isn't large enough to handle that, then you run the risk of it tipping over or slowing down. And that's just not acceptable when it comes to especially managing the regular tasks that the management server does. So that's the second problem. The third problem is when it comes to billing, it just doesn't give you the level of detail that you might need. So, for example, when a virtual machine is created, there are a handful of events, maybe 10 of them, that are just for they happen when the VM is created. So the first event might be the request to generate the VM. After that, you might get an event for, when CloudStack starts to handle that request. And then the next event might be when the VM begins to be successfully created. And then after that, you have an event saying that the VM has successfully been created. And then after that, you might have an event that says the VM has started, right? So along the way there, that begs the question, which of these events do you want to listen to when it comes to determining the start of that VM when you want to start billing the customer for that? Do you want to bill them starting when they first request it, or do you only want to start billing them once it's been fully provisioned and started? So for us, it only makes sense to bill the customer once the VM has already been successfully provisioned and started. But with the usage service, you don't get that level of granularity in the events or the control over exactly when you want to start and stop your billing. Similarly, when you're deleting a VM, there are multiple events in that life cycle. So, do you want to stop billing the customer right at the point when they request the VM to be deleted? Or do you want to wait until the VM has been successfully deleted? Or do you want to wait until it's been successfully expunged? So, if you don't pick the right events, then you run the risk of billing the customer over a longer time window than they should have. So if the I don't remember which event the usage service uses to consider the end of a VM, but if the delete is the last event and the management server gets stuck trying to expunge a VM, you might end up billing a customer for a VM that doesn't exist anymore, but also hasn't been deleted from CloudStack, if that makes sense. The next problem is that when it comes to the usage service, you still just end up with a pile of timestamps and configurations. And that still requires you to build an engine that puts that information together, collects each of the resource usage by the account and the resource type. And then you need a way to apply a costing algorithm to each of those resources. And then once you have all of that, you still need to create a bill. You might want to create an invoice from that bill, and then you want to email that to the customer, and then you also want to process a payment. So these are all things that, to be fair, are outside of the scope of what the usage service is meant to do, but they're still things that we needed in our billing system. And it made more sense for us to build a new system that does all of the metering and the calculations, and then also has plugins or modules to do things like invoice generation, sending out emails, and payment processing. And then the final problem with the usage service is because it runs on the management server itself, it can't be scaled out horizontally, and it is also not, it doesn't have built-in redundancy. So with our system, the way that we designed it is our billing engine can actually be scaled out horizontally. You can have multiple replicas running in parallel, processing these different events, putting the data together. And not only does that offload the resources from the management server when it comes to metering for usage, this also means that as the amount of resources managed by CloudStack scales up, we can also scale up our billing engine to handle more events, more resources, and things like that. All right. So let me talk a little bit about the design of our billing engine. So when we decided that we needed to do it, when we needed to build our own, we ended up looking at the CloudStack events themselves, and the schema of those events contained enough data that for virtual machines and VPCs and Kubernetes clusters, all the resources that we want to build customers for, we found out that those events actually contain enough data that if we track them over time and put them together, map them to resource events, we can build the state of those resources and have that accurately reflected and agree with whatever's in CloudStack. And it allows us to track changes to resources over time. It allows us to track exactly when a resource was created and when it was changed and when it was deleted. So having those events was great, and that allowed us to figure out how to start ingesting those events. So there is a CloudStack event bus which can be hooked into, and at the time when we started building this, you could only have one adapter or one consumer connected to that event bus at one time. Now you can actually consume events from more than one connection to that event bus, which is great because what we did was we built a Kafka adapter and we built a RabbitMQ adapter. So one of the nice things about being able to have multiple event consumers at once is that you can have those events feed into both systems. You can use one as a witness if you want to check your data, or just simply as a backup. Or you can just run one or the other if you really prefer Rabbit over Kafka or vice versa. Yeah, both of those adapters are not too complicated. And one of the nice things about using a message queuing system as a sync for all these events is that, number one, you have long-term data storage. It almost acts as its own database. And secondly, you can replay those events. If you change the offset, you can replay those events, reprocess them, and then that can be useful if you have any algorithm changes or if you need to rebuild the database for one reason or another. And another cool application of using a publisher subscriber model is that, as I mentioned, you can have multiple replicas of an engine running connected to the same message queuing system. And each of those events, as they get processed, will only go to one of those replicas. So you never run the risk of processing the same event more than once. And you don't have to write your own load balancer to make sure that those events go just to one replica of your system. So that was another reason why we went with Kafka. And then on the database side, we're using Postgres, and we have redundancy set up there. So the billing system itself just sees it as a simple Postgres database, but we have replication built into that. And so we have redundancy on that front as well. Next slide, please. All right. So this is an expanded model of our billing system, basically. So if you look at the top section there, that big orange box is the Kafka cluster itself. So it contains two main topics. On the left-hand side is the CloudStack topic. This is where all of the CloudStack events go from the management server. All of those events go into that topic, and they're spread across multiple partitions. And then on the right-hand side, we actually have our own extra topic for events that are specific to our cloud platform. So this way we can inject extra billing specific events into the system, but this might not be something that everybody wants to use. This just allows us to inject other billing type events into the system to be processed by the billing engine replicas. So focusing on the center, those green boxes are the billing engine replicas. The center one is just an expanded view. So you can see how the events feed into the Kafka event consumer on the top, and then those all get mapped to these resource events that are shown in the database tables below. So under the database cluster, there's a main event log table. This is where all of the event logs get processed. And the reason that they all go into a single database is that this allows us another layer to store the data and also to replay the events. And the event processing is very quick because it's basically just a mapping step where it processes the event log. It asks, okay, does this conform to the schema of an event type that we want to process? And so a lot of the events we just skip, but we log them anyways because we might want to process them again later in the future. But the interesting part is that those event logs, if they do meet the schema that we want to process and map, then we map those to resource events. So the second table from the bottom, you'll see VPC events, Kubernetes events, virtual machine events, right? So as these events come in, they get mapped to these tables. And what this means is if for one virtual machine you have, say, 50 events over the life cycle of that virtual machine, you can very quickly and easily process those events in the VM events table and build the state of that VM, which is the table underneath that, under the very bottom. Those are the resource representation tables that will show the current state of whatever the resource is, as well as any changes that have been made to it over time. So if you have a virtual machine that has undergone a couple changes over its life cycle, those are all going to be tracked and logged in that bottom virtual machine table. And then from that, it's very simple to construct a bill for that resource, right? And since all the resources are attached to one CloudStack account, you can go through all the tables, figure out the start and end points for each resource, what the costing algorithm should be for each of those time windows, and then collect them all together and then construct a bill for one CloudStack account.
Yeah, before we go to the next slide, I did want to call out one item here. So I think it's important to kind of delineate that for our purpose, right, that cloud platform subscription topic and, the subscription management and invoices and payments module, those are pretty specific to our use case. But the CloudStack topics and the event log and all the different the events that we are tracking could be extended out, right? And this is kind of where we see this as an agnostic CloudStack usage service. We've obviously built some things for us and for our use case, but I just wanted to call that out, that underneath it, there is a very agnostic layer that we're excited about that has made, tracking and projecting CloudStack usage a lot easier. And I just wanted to call that out because that'll tie into kind of a question that we asked later on.
Yeah, thanks, Aaron. Yes, so just to recap, what we ended up building was a system that can display real-time resource status, configuration, and costs, both to customers and administrators. Because the data is real-time, we can also trigger payments immediately after a certain event is processed. We can also trigger credits and refunds at the same time, instead of having to rely on batched and scheduled jobs. We can also monitor usage and very easily run projections because of the level of detail and immediacy with this data too. And because the events are stored in Kafka, we can always replay the events if the event algorithms change, or if we need to reconstruct the database for one reason or another. One common thing that this helps us out a lot with is actually creating new test accounts and test environments. They can register as a new event consumer, process all of the messages, and then we have a new test system up very quickly that has data reconstructed going months and months back. This also allows us to add in other services as modules, and we can also add whatever other topics that we want and inject extra messages that can help us with billing. Anything else that we want the billing system to process, those events can just go in their own different topics. I think that's it.
Sweet. Thank you, Ben. Thanks for going through that. So now that question that I was kind of talking about, so we're going to open up the floor now for Q&A. But as we do that, we do have one question for all of you. And if, if you're watching this later on and you're not here live, we will throw contact information out because we're very interested in, we want to know if this new usage service is of value to you guys. And if you'd like us to open source it, obviously we would pull out the specific billing logic that's, for us specifically, but the CloudStack usage side of it, we're interested in contributing back to the community if you guys want it. So I'll shut up now and kind of hear from you guys if you guys have any questions for us.
Yeah. Thank you very much, Ben and Aron. Surely looks very, very interesting. I'd like to take that answer. So the question and answer it. So yeah, it surely looks very, very sufficient and interesting. And I'm sure people would love to try it and would love to experiment with it. It kind of makes solves a lot of problems that you listed, and it makes much sense as you displayed it. And I'm actually going to counter that question with, how do you plan to donate that and to contribute that to the project? I mean, it will be, I'm sure people will be interested in that and will be experimenting. So do you have any plans?
Yeah, that's a great question. Giles and I talked about it a few months ago, and we talked about us kind of presenting this idea here at this conference, which we're excited to do. And the short answer is we don't have a specific way that we need to donate it. So we're open to whatever is best for the community. If it's better for us to open source it and maintain it, or if it's better for us to donate it to CloudStack, we're open to any route that's the most valuable for this community because, we love this community. We've been a part of it for a long time. We've been using CloudStack for close to a decade. And anything we can do to kind of further make CloudStack better, we want to participate in.
Cool, sounds great. So yeah, let's stay in touch and we'll figure it out, I guess. So yeah, I guess the floor is open for questions. Dan, I'll translate your question.
I'll do it in English.
Yeah, I'll resend your question. Sorry.
Okay. So there was one thing that I was wondering about in your problem statement. I like the use case in general, but there was one thing where you said that the usage server cannot run on a different server. And I have been doing that, and I think that's not the case. So I was wondering what you encountered while you tried that. Is there any specific, do you remember anyway?
Did you hear that, or you want me to say it?
Yeah, I think I heard most of it. I think the question was, you've been running the usage service, the current CloudStack usage service on its own server, and you haven't been running it on the management server, and you were wondering why we ran into the issue with running it on the management service. I'll let Ben take it away, or I can take it either way.
Yeah, at the time when we started building this, which was maybe over a year ago, that was the only way that we could figure out how to run the management server or the usage service. So it's possible that we missed that option, but I also don't know if maybe that's a newer feature.
And I think for us too, right? Sorry, and I think for us too, right, is that was kind of only one of the limitations. So we probably and I don't remember because like Ben said, it was over a year ago. We were kind of facing several issues, and we probably stopped looking at trying to put it onto its own server because we had multiple issues to run the billing service that we needed to. So ultimately, we decided to just kind of start back from first principles, figure out exactly what we needed, and ultimately made more sense to kind of build our own using CloudStack Events rather than the usage service.
No, very clear, and it's not the most important part of your use case. So that's a great answer. I was wondering about the usage database. I'm guessing you're creating your own billing database. and you're not feeding back into the existing cloud usage database or the cloud usage table in the cloud usage database, are you?
Yeah, that's correct.
That's correct.
And, you know, part of that is because for us specifically, CloudStack is a big major component of our orchestration layer, but it's not the only one. And so we're really using this, and what we call it internally is we call this our core service. And that's because we've got multiple orchestrators, and we also have like a customer management layer in there. And so all of this data is getting ingested into core, into this usage service, and then being stored in its own database.
Okay, then comes my only real worry about your solution, because I love it, but quota. There's a quota plugin, and I'm guessing you're not using it.
So the quota plugin works inside of CloudStack, and it also works across to our customer management layer. So the quotas are actually in sync, and it does work. That we could kind of dig in under the hood when we have more time, and I'm going to throw up my contact information at the end, and we can kind of get into the nuts and bolts of like our specific platform. But there's nothing in CloudStack, or there's nothing in this new usage service or core system that prevents the use of anything in CloudStack. It's all extendable, you know, from end to end. And that's kind of the way we intentionally wanted to build it, is we didn't want to create any walls in the future because we know CloudStack's going places. We've seen it go places already. And there's a lot of new feature development. And the last thing that we wanted to see was, oh, CloudStack, the community comes out with a really cool feature, but we can't leverage it because we've kind of built ourselves into a wall.
Makes total sense. Any other question? All right. I think we're just about out of time. So big thank you, Aron and Ben, and it's been a pleasure.
Yeah, I'll throw my contact info up here if you guys want to take a picture, or you can go to americancloud.com and reach out. Just say, hey, I was at CloudStack Conference. I've got more questions. We did run out of time. We were thinking about showing kind of a quick 30-second demo of just, you know, the usage service kind of going through a live scenario, but we'll save that for one-on-ones. So reach out to us. I hope you guys all travel safe home. And we really appreciate the CloudStack community inviting us to talk about this. And we can't wait to see what the future holds with everybody here.
Thank you very much. See ya.
Thank you.